Okay, so in our previous lesson, we talked about whether a sample is a biased sample or an unbiased sample. So therefore, is it valid or is it invalid? Now we're going to talk about, okay, so if we used an unbiased sampling method, so therefore it's valid, then now how can we use that information to help us make predictions about that information? So example 1A says a guidance counselor randomly surveys 30 seniors about their post-high school plans. The table shows the results. Predict how many seniors out of 180 will begin studying for a bachelor's degree after high school. So it's actually going to come back to a proportion. So I'm going to look at what I know. So we're talking about studying for a bachelor's degree. So it looks like there were 17 that said they were looking into getting a bachelor's degree after high school. So 17 out of those 30 seniors surveyed were saying they were looking at getting a bachelor's degree. Now we're wanting to make a prediction about the entire population of the 180 seniors. So it's that part to whole thing. So 17 is part of the kids surveyed who said they wanted a bachelor's degree over the 30, which was the whole amount surveyed. The 180, it represents the whole, and then I'm trying to figure out, well, based off of this, then how many would I expect out of 180? So again, comes back to a proportion. So multiply across 17 times 180, divided by what's diagonal from the variable, so divided by 30, and I've got my answer, which I would say is 102. Okay, so predict how many seniors out of 180 will begin studying for a bachelor's degree. So I would predict 102 seniors to begin studying for a bachelor's degree. Now, sometimes kids are a little confused by that term prediction. They think, well, it's just a prediction. Can't I just pick a number? Well, it should say mathematical prediction. Based on the information we're given, we're not just randomly making a prediction. We're making a very educated, problem-solved, mathematical prediction. So that is why, based off of this information, there is only one right answer for our prediction, because it's not a random prediction. It's based off of the data. B says a town is organizing a summer festival. The planners want to have enough gift bags for every person who attends. Out of 100 people randomly surveyed, 47 said they would attend the festival. So right now we're at 47 out of 100 said they would attend. How many gift bags should the planners prepare if there are 2,800 people in the town? So 47 out of 100 surveyed, and we're wanting to know out of 2,800, so again, that's the whole. We're trying to figure out what part of that 2,800 is, and then again, I solve it the same way I solved on A. 47 times 2,800 divided by 100. When I do that, I'm going to get 1,316. So they should prepare 1,316 gift bags. Okay, example 2. An employer is planning to buy lunch for all his employees. The graph shows the results of a random survey of his employees. And notice all these say something about random. That's telling us it was an unbiased approach because it was a random survey. Random is good. That's what we want. That means it's unbiased. Of his employees' lunch preferences, how many Italian sandwiches can the employee expect to buy if he has 84 employees? So they're talking about Italian sandwiches. So it looks like Italian was 25%. Percents are out of 100, so I'm going to put 25 over 100. And I'm wanting to know, well, so then if he has 84 employees, so in other words, I'm trying to figure out what's 25% of 84. So if I'm using a proportion, remember we also learned the percent equation. I mean, that's an option. But since I've done the others with a proportion, I'm just going to stick to that same method, even though I'm dealing with percents now. So 25 over 100, 84 would be the whole, and I'm trying to figure out what 25% of that is. So 25 times 85 divided by 100, I've got my answer, which in this case is 21. So how many Italian sandwiches should he expect to buy? So he should expect to buy 21 Italian sandwiches. Okay, B, an usher finds that 13% of the fans seated in his section bought a game day program. About how many fans will buy a program if 60,000 people attend the game? So again, I'm given that percentage of the people who bought this game day program. So 13% is 13 over 100. And he wants to know about how many fans will buy a program if 60,000 people attend the game. So 60,000, that's the whole. Set up my proportion, solve it. So 13 times 60,000 divided by 100. I get 7,800. So about 7,800 fans will buy a program.